of people forget about these as soon as we move on to other kinds of straight lines, but please don't. So, when we looked at gradients, horizontal lines and vertical lines are slightly special. Okay, so we don't really generally look at their gradients as much. Horizontal lines have what kind of gradient? Horizontal line, what's the gradient of a horizontal line? 0. Okay, it doesn't rise up. Oh my gosh, it doesn't rise at all, and it runs a lot. How do we talk about a vertical line? What gradient does a vertical line have?
The run is 0, but the rise is a lot.
And so how do we describe that? What special word? Undefined. Okay, so an undefined gradient is a vertical line. So horizontal lines have gradient of 0, and vertical lines have an undefined gradient. Okay? There's the end. If asked to plot the following coordinates, what do we notice? Okay, so if we were plotting these coordinates, can you plot them for me and see what you get? Perhaps plot these ones in one colour, and these in another, these in another, these in another. Okay? Okay, so hopefully you got something looking similar to what I got. So let's look at the first row. The first row are the ones that I did in red. Okay? Firstly, tell me, looking at the coordinates, before we look at the points, tell me something about those coordinates. So is there anything that you can tell me about those coordinates? Judy?
They all go across positive 2.
Okay, so what value, what do we normally call this part? Pardon? The x. Okay, so for all of these, the x value is 2 for each of them, yes? Let's have a look what they look like. So looking at my red crosses or whatever colour you had, what can you see about all of those coordinates? Emily? They're in a vertical line. Anything else special about it? Whereabouts is that vertical line positioned? It goes through the 2 on the x-axis, yeah? Okay, so these points here, these red coordinates, all are in a straight line. They go through the value of 2. So this would be known as the equation x equals 2. That's how we would describe that line. Okay, because our x value is always 2. It doesn't matter what the y value is. It's a vertical line, and it goes through the value 2. So the second one, hopefully, we'll talk quite quickly, that one has an x value of what? Negative 3. And again, you should have found that it was a vertical line going through negative 3. So that green line, or my green line, would be known as the equation x equals negative 3. For the second 2, okay, what's the same for the second 2? The next horizontal lines, and looking at the actual coordinates themselves, which part is the same? None of them are the same. So for this one, okay, so the y value is this time the same. Okay, so for this one, they all have a y value of 3. And the second one, they all have a y value of negative 4. And again, that would be known as the equation y equals 4. Totally 3, because it goes through 3. Well done, Jada. Keep me on my toes. And the other one would be y. Oh, shush now. Equally that straight. You're going to do that. What? Oh, y equals. Oh my word. Y equals negative 4. Okay, so there are our equations of our lines. So, as it says, look at the coordinates for each lines drawn. We found length we predicted what the equation of the line would be. Okay, this is the other thing that's important. You do have to have that equal sign to make sure it's an equation. Okay, so people get a bit freaked out by saying it's x equals 2, x equals -3, y equals whatever. You must have that equal sign in, and this is now the equation of that line. Okay. Alright, so vertical lines have an undefined radius and they have the general form of x equals a number. Horizontal lines have a gradient of 0 and have a general form of y equals a number. Okay, so x equals a number and y equals a number. So can you try and label or name those coloured lines, please? I think you've got space at the bottom to write it. Or you can write them to the side if you prefer. Okay. Alright, I'm hoping this didn't take too long. So what would the equation of my green line be? What? X equals -6. Good. Again, you have to have the x equals or what? The blue line. What's the blue one? There's the ends. And this bad boy, I don't know what colour is that? Orange. Orange one? X equals 8. X equals 8. Oh. Okay, so the orange was x equals 8. The yellow would be
Y equals -4.
y equals -4. The red
Y equals 3.
and the purple
Y equals 7.
7. Alright, so we're good with that. Now, linked to that questioning just now is it does confuse people because we know that this horizontal line here is known as the x-axis. Yes?
Yes.
But it also has an equation of a line. Okay? How would I describe this x-axis as an equation of a line following the rules that we just talked about? Laura?
So if you're describing
We're talking about this horizontal line.
so would it be y equals 0?
It would be y equals 0. Okay? So the x-axis is also known as the line y equals 0. Okay, just to throw people all of a dither. Because we know it's a horizontal line. The x-axis. So that one is a horizontal line. And we've just talked about the fact that horizontal lines are always of the format y equals. And the value of y across here is always 0. And so that's why the equation of the line is y equals 0. Okay? So when you're describing this horizontal line here, you can either say the x-axis or the line y equals 0. Yep. Also, or in a similar vein, what's the y-axis going to be called? X equals 0. Okay? Alright. Okay, so that's horizontal and vertical lines. So they do come up. You do need to be paying attention to them. So if asked to plot or draw any kind of function, oh, now we've done this, haven't we?
Yeah.
This is what I left you to do. Yes? So this is where we filled in those tables of values and we had lines. Now, I didn't really go over it much with you today. Did I know? Well, I didn't actually discuss what you had. I was supposed to come around and check them. Looking at the graph that you drew here for y equals 3x minus 1. Okay, so you chose the values, you drew your line. Is there anything that you can tell me about the graph or the line that you drew that connects itself to the equation that we were given? Is there anything strikingly obvious that might lend itself to giving us a clue about the equation? Alexis?
I was going to say the -1. One of the points is -1, 0. I mean, 0, -1.
Okay, so we found that one of our points was 0, -1, and we had a -1 here. Okay, let's look at one of the other graphs that you drew. Is that the case here? So what about the -3x plus 2? I asked you all to make sure you did a 0 for x. What value did you get here?
2.
Okay. Oh, so that's looking quite good. What about the next one down?
0 and 5.
0 and 5. Well, that's interesting. It's written in a different order, but this would be negative half x plus 5, would it? Do you agree with that?
Yeah.
So this number stuck on the end is the same here. What about this one?
0, negative 1.
0, negative 1. So hopefully you can see from each one of those that that end number tells us something about it. Now, where is that point when we plot it? Oh, that wasn't
The y value.
How do you mean the y value?
It's on the y-axis.
On the y-axis. Excellent. Okay, do you all see that? So if you look at all of your lines, I know that this line here crosses the y-axis at this value. Or it should do. I know that this line here crosses the axis, the y-axis at that value. I know that that first one we drew crossed at negative 1. So for each of the lines you drew, other than the very last one, that end value should have told you where your graph crossed the y-axis. Now I'm going to get you to have a look at another feature we've been looking at, gradients. Have a look at the gradients of those lines that you drew, okay, and tell me something about those. All right, so have a look at those first, and then we're going to discuss that. Start with it, okay, after having had a bit of a discussion. All right, so we found that the gradients of the graphs all match whatever value it is in front of the x. Okay, so what we need to be careful of is that we're not saying things like the first term. So all this one is, the first term is 3x. But the important thing that it matches is it's the coefficient of x gives us our gradient. Okay? So the gradient is always determined by that first number, or the number in front of x, or the coefficient of x. And the y-intercept is determined by that final number. Okay. So we have a new pack. I think we've now completed this pack, yes? Have I given you the next new one?
Yes.
Yes, I think you have a whole brand new blank pack.
Which one?